Welcome back students to yet another video of A to Z studies. Today we will be starting with the second chapter of physics, that is physical quantities and measurement. Again we have split the chapter into two parts so that the videos are short. First of all, we will start with the concept of density. In our daily life, we have experienced the fact that some things are lighter and some things are very heavy. We call it heavy. Like if we have a metal things with us, a metal spoon or a book, we call it heavy. And at the same time, if we have a stuffed toy, the teddy bear, or a piece of foam, we call it light. Right. So here we can see we have a metal ball here, metal sphere, metal ball, and here we have a wool ball. Wool ball. Now if we have the same mass here, for example, this is also 1 kg and this is also of 1 kg. We will see that this metal ball will be small. A small dimensions of this metal ball will make up 1 kg. But to make, if we have 1 kg of wool, it will be big enough. It will be a bag full of wool. Now let's move on to the second scenario. Again, if we have, here we have the same dimensions, two bars, one made of wood, this is made of wood, and this is made of metal, iron or copper, whatever. Now they have got the same dimensions, but if we weigh them, if we measure their weight, we will see that the wood is having much less weight than the metal. Why is it so? The answer is density. Right. Let's have the definition of density. Density of a body is defined as its mass per unit volume. Mathematically, it's very easy to calculate density. We will have the mass of the body, we will have the volume of the body, and if we divide mass by volume, we will get the density. So let's see what are the units of density. Units of density can be derived by using the formula unit of mass divided by unit of volume. So what is the unit of mass? In SI system it's kg, and the unit of volume in the SI system is meter cube, right? So in the SI system, the unit of density is kg per divided by meter cube. We can write it like this, or we can, but in while writing we do not write like this generally. We write like this. We may write like this, kg slash meter cube, or another form of writing is kg meter to the power minus 3. This is also kg per meter cube. Both are correct. Now this is the SI unit. We have another unit which is the CGS unit. This is also used sometimes and the sums might come in this unit also. This is grams divided by centimeter cube. Centimeter cube. Or it may also be written as centimeter cube, can also be written as cc, centimeter cube. So we can be written as grams per cc. Another unit is there, but this is rarely used. This is the FPS system. This is LB, means pound per cubic foot. LB per cubic foot, like this. But this is rarely used nowadays, and sums or problems do not come in this format generally. So let's move on to the next slide. Relationship between unit of density in various systems. So there might be some questions in which it's given the density is given in kg per meter cube, you have to convert it into grams per centimeter cube or vice versa. The thing is very easy. In SI system, this is 1 kg divided by 1 meter cube, cubic meter, whatever you say. Now 1 kg is equal to 1000 grams and 1 meter is equal to 100 centimeter, we can write. Therefore, since it's a cubic meter, see it's a cube, we will write 1000 divided by 100 into 100 into 100, 3 times 100, right? This is grams and this is centimeter cube. From we just converted from meter to centimeter, and again I am telling, since it's a cube, we have to multiply it 3 times. Now if we just cancel out the zeros like this, see we are left with 1000 as in the denominator. So we will get 1 by 1000 grams divided by centimeter cube is equal to, now if I convert it into standard form, 10 to the power minus 3 grams per centimeter cube. This looks nice while writing. Thus 1 kg per meter cube is equal to 10 to the power minus 3 grams per centimeter cube. Also the reverse, if the question is coming, we have to convert from 1 gram per centimeter grams per centimeter cube to kg per meter cube. This is the formula. We can derive this same thing like this, but you first try it out, and then if there is any problem, we will discuss it in the another video. Okay. 1 gram centimeter cube is equal to 1000 kg meter cube. This is very easy to remember. So you can remember this relation. It will be easy for you. Moving on to the next slide. The vessels for measuring volume of liquids. We see here generally 3 things. Measuring cylinder. Measuring cylinder is generally it's a slim, it's the diameter is less but the height is more. Here is a beaker. A beaker, in both the cases there are calibrations. In beaker there may or may not be calibrations. In measuring cylinder there are calibrations. And this is a Eureka can. This is just a lab format of the kettle that we use in our homes. This is a spout. This is the spout, and actually this is, the spout is like this. Okay, the spout is like this. Now up to this level the water is filled. Now if the water is filled a bit more, if we pour a bit little more water, the water will flow down and we can collect it, right? I didn't get a good diagram of the Eureka can, so I put it like this, but the idea is same. The spout is a bit lower. Okay. Determination of density of regular solids. What are regular solids? See, this is a block of substance, block of wood or block of metal, whatever. So it is a regular. It has got a specific length, breadth and height. Regular solids may be a pyramid, a hexagon, hexagonal pyramid, a triangular pyramid, tetrahedron, all these are rectangular, regular solids. A sphere, a cone, a cylinder, of course. A cylinder, I forgot to mention the diagram. A cylinder is a regular solid. Now we can easily find the mass. How can we find the mass? Uh, by putting this on a scale, be it a beam balance or a electronic balance or a spring balance. We can measure the weight. Beam balance or electronic balance. The electronic balance are what we find in the grocery shops nowadays, or a spring balance. So by these three instruments we can find the mass, right? Now we can find the volume easily of regular solids. In this case, the volume of this is length into breadth into height. For this, the sphere, the volume is 4 by 3 into pi r cube. For the cylinder, the volume is pi r square into h. So for every regular solids there is specific formula from which we can get the volume, and we can easily measure the density is equal to mass divided by volume, right? So this is very easy to determine the density of a regular solid. You can also try it at home by taking any regular solid like a book. It's a regular solid. You can get length, breadth and height. A cricket ball, you can measure it by measuring the density, diameter. Now let's move on to how we can determine the density of irregular solids, because they do not have any length, specific length. You cannot measure the length or breadth or diameter, because there is nothing specific. For example, in this stone you cannot find it. So but a very easy way of finding out the volume is you take a measuring cylinder. Now what do? You first fill it up with water, so that you have the, when you immerse the solid, the solid will be immersed completely. It's not that a part of it will remain above the liquid. You put in the adequate amount of water in it. Now before immersion you note the level of water. Okay, now we immerse the solid in it. We will notice that the water level rises. For example, the water level comes here. Now we will note the reading here. Now the volume will be given by pi r square h2 minus h1. Let this height be h2 and this height be h1. Pi r square, r is the radius of this measuring cylinder. It will be specified in the cylinder itself, or the volume might be ready-made given or readily given. the calibration may already be given in the volume itself, liter itself. Okay. So, or if the volume calibration is given in volume directly, then volume is equal to V1, sorry, V2 minus V1. We will get it readily. And if the calibration is in height, then we have to use this formula to get the volume of the solid. So this is the volume of the solid that we have dipped in it. Now again, and we can get the mass of course by using a beam balance or any type of balance as mentioned before. So we can get the density again using the formula mass divided by volume, right? We can see if we don't have any measuring cylinder, we can use a, or if the object is too big to be immersed in a measuring cylinder, we can use this process also. We can take a kettle that we have in our home, we will just fill it up with water so that it the water level is just at the mouth, this level. Adding a drop of water will make the water fall down, right? We'll take it is just at this brim. Now we will again dip this water and we will see that water will fall down, the extra water will fall down. We will collect this water which has fallen down and we will measure the volume of this water in the same way. Now this we will, here also we will get the volume of the stone or irregular solid. We will also measure the mass by beam balance or any type of balance that we can get. Again we will find the density is equal to mass divided by volume, right? Now we will learn how to measure the density of any liquid using a density bottle. A density bottle is a specifically designed bottle which has got a stopper which can be pulled out, and after filling it with liquid we have to put it back in, and any excess liquid will flow out of this outlet. So there will always be a specific amount or a particular amount of liquid inside the bottle. The capacity of a density bottle is fixed. For example, it can be, there can be 50 ml or it can be 100 ml, like that. We have to keep in mind that the density of water is equal to 1 grams per centimeter cube. This value is needed. First of all, we measure the mass of the empty bottle using a beam balance or a electronic weighing scale. So let us assume the mass or weight mass of the bottle is m mass of empty bottle is equal to mb. Okay. Then we fill up this bottle with water and then again we find out the mass. So in this, now let's assume mass of bottle plus water is equal to, we denote it like mb plus w, and then we again drain away the water and pour in the liquid, fill it up with the liquid of which we want to measure the density, and then again measure the mass of the liquid. Bottle, mass of bottle plus liquid is equal to m, let us assume it is m b plus l. Therefore mass of water is equal to how much? It's m b plus w minus mb, mass of bottle plus water minus mass of empty bottle, and mass of liquid is equal to mass of b plus l minus mb, mass of bottle plus liquid minus mass of empty bottle. Now we have the formula. What the formula is? Density of liquid. So I've forgotten to give the, let's all the units be in grams. Okay, all the units are in grams. Now density of liquid is equal to mass of liquid in grams divided by volume of liquid in centimeter cube, right? So mass, again I will again write the formula. Mass of liquid is equal to, sorry, density of liquid is equal to mass of liquid in grams divided by volume of liquid in centimeter cube. Now mass of liquid, we already know it is m b plus l minus mb in grams. And what is the volume of liquid? Volume of liquid in centimeter cube. We will find this out. Now density of water, we keep this as it is. Now density of water is equal to, we know, mass of water divided by volume of water. From here we can write, implies volume of water is equal to mass of water divided by density of water. But the density of water is 1, is equal to mass of water. We know what is the mass of water. We have measured it. That is m b plus w minus m b, mass of empty bottle in grams. And what is the density of water? It is 1 grams per centimeter cube, right? Is equal to, I can write, this grams will cancel out and this centimeter cube will go up. So it's equal to m b plus w minus m b centimeter cube. but this volume of water is equal to the volume of liquid, because the volume, the capacity remains of the bottle, density bottle remains the same both in case of water and in liquid. So the volume of water is equal to volume of liquid. So volume of liquid can be written as this one. So we can substitute this value in this volume of liquid. Therefore, density of liquid is equal to m b plus l minus mb divided by what? M b plus w minus mb, and the unit is grams per centimeter cube, right? Now one thing, it can be seen that there is no factor of volume out here, only the masses are there. So by knowing only the mass, measuring only the mass, we can find out the density of liquid. This experiment can be done with any bottle we have at our home, like any glass, any 500 ml bottle, 1 liter bottle, 200 ml bottle, any type of plastic bottle, glass bottle, ceramic bottle, any kind of bottle, or any beaker if you have. So you have to keep in mind that the volume remains constant. In both the cases, the volume are measured, the bottle is filled up to the brim in both the cases of liquid and water. You can do this experiment with liquids such as, if any household liquid like oil or alcohol or sanitizer. So you can measure the density and you can get a weighing machine if you have at your home, or you can get help of the nearby grocery shop. You can do this experiment at home. Okay, so let's move on to the next slide. Now let's come to relative density. Relative density is defined as the ratio of density on the substance to the density of water. As it is a ratio, it does not have any units. Now whenever we talk about relative to anything, we find it easier to express it. Okay, for example, if I tell the density of iron is 7.8 kg per meter cube, sorry, grams per centimeter cube. The density of iron is, for example, 7. It may vary, but generally this is the value. It may vary a bit, not much. Grams per centimeter cube, or 7800 kg per meter cube. If I tell you this, so you might not have the idea of it. You might think, how much is 7.8 grams per centimeter cube, or how much exactly is 7800 kg per meter cube. You might not have that idea in mind. But if I tell you that iron is 7.8 times more dense than water, or 7.8 times heavier than water, then you will have that idea. Oh, acha, we all have the sense of that water, no, the density of water. If I tell you honey is density of water, we have the idea in mind. Okay, honey is denser because it's more stickier than water. Alcohol is less dense than water. Oils are less dense than water. So we have that idea, we that something clicks in our mind when we have some relative to water, because water we see it every day, every time. So when we tell it the relative density, we just tell the relative density of iron is 7.8. If we tell the relative density of iron is 7.8, or the relative density of mercury is 13.6, we immediately understand this mercury is 13.6 times heavier than water. Right? Or if we take the same volume of mercury and water, that mercury is going to weight 13.6 times that of water. Right? So think carefully. Now, relative density, now the formula is relative density is equal to density of substance divided by density of water. We can find out but the unit has to be the same. It's not like density of substance we are giving it in kg per meter cube, and density of water we are expressing it in uh, grams per centimeter cube, and we are doing it, then the entire thing will be wrong. Thus units has to be same. For example, the density of mercury, let us take the example of mercury. It's 13,600 kg per meter cube. If we weight 1 meter cube of mercury, it will weight this much. It's huge. Now if we weight 1 meter cube of water, we will find that it's only 1000 kg. Right? Now in this we put both the values in this formula. The density is kg per meter cube. The density of water is 1000 kg per meter cube. Now if we do the calculation, these units will cancel out. We can cancel it like this. So the thing will come to be 13.6, and it will have no unit because the units are cancelled out. We will only tell it's the relative density of mercury is 13.6. Also, we will come to it later, but I can just give you, we will just have a short discussion. Like whenever, for example, iron, what will happen if we drop a coin, 1 rupee coin or 5 rupees coin in water? The iron will sink down because the relative density is more. And what will happen if we put any object made of thermocol or plastic on water? It will float. So if we find out, the relative density of the thermocol will be less than what? 1, less than that of water, right? That is less than 1. We will discuss it in the next video, or the principle of flotations and everything we'll discuss. It's just I gave you a glimpse. Now again, how can we measure the relative density of a liquid? So in this way we can measure the relative density of a solid, right? But how can we can easily measure the relative density of any substances. Density of substance we can find out by the earlier processes, like measuring the mass and dividing it by the volume of the substance. Density of water we already know, it's a standard thing. Now how can we measure the density of a liquid? Again, that can be done using a density bottle. Again, as we have discussed before, let's keep it short. I'll tell you, I will just omit the detailed thing. We measure the as before, we measure the empty bottle first, then we measure the mass of the bottle plus water. So let's term it mw is equal to mass of bottle plus water minus mass of bottle. M liquid is equal to mass of bottle plus liquid minus mass of bottle. Now what will be the relative density of the liquid? Relative density of liquid is equal to density of liquid divided by density of water. Now we already know the density of water has to be 1. And how can we measure the density of liquid? How can we find out the density of liquid? Just by the earlier formula, that is mass of liquid divided by mass of water. So we have got the formula mb plus L minus mb divided by mb plus W minus mb divided by the whole thing is divided by, because this is the density of liquid, this entire thing formula expression is the density of the liquid. Now we divide the whole thing by 1. The units are here, we still have the got the units because these are the densities. This will be grams per centimeter cube and this is 1 grams per centimeter cube. Now here at this place, at this stage, the units will cancel out and see the whole thing again divided by 1 gives us this thing. Therefore the relative density of liquid we can write as mass of bottle plus liquid minus mass of bottle divided by mass of B plus W minus again mass of bottle. So this gives us the relative density of the liquid. Okay, so we keep it up to this. So we will be continuing with the next part in the next video. Till now, if you have any doubts, if you have any questions, please ask me and please keep me motivated. It will take a very small time to do that subscription. Okay, thank you for being with me. So meet in the next time. Bye.